Hi, welcome to my video on defining sinusoidal axis, amplitude, frequency, period, and phase shift in pertaining to the sinusoidal functions. I have four graphs here, so I'm going to use the graph to explain each of these terms. The sinusoidal axis is the axis of symmetry. It's the horizontal line that passes through the middle of the curve. The equation is y equals k. In this equation, which is a sine b theta minus h plus k, or in cos equation. Let's find the sinusoidal axis of each of the above. So the sinusoidal axis passes through the middle. So the middle of the curve is right there. So that's passing through at 2. So the sinusoidal axis is 2. Y equals 2. In number 2, the middle of the curve, the highest is positive 4, the lowest is negative 4, so right in the middle is right here. So the sinusoidal axis is y equals 0. Half above, half below is split. The sinusoidal axis here is going to the middle, so there's the curve. Notice the S shape, sideways S. Half is above, like here, and half is below. So it's y equals negative 3. And the sinusoidal axis here is right there. It's y equals 1. So the sinusoidal axis is the axis of symmetry. Let's take the graph into, I won't say equal pieces, but keeps it symmetrical. Another term that we'll use is amplitude. Amplitude is the perpendicular distance from the sinusoidal axis to the highest or lowest point on a curve. So the same graphs again, but I'm just doing different. I did them in different pages, so when I mark them up, we won't get confused. So the sinusoidal axis here is y equals 2. So the perpendicular distance is from here to here. So that's a 2. So the perpendicular distance is 3. So the amplitude is 3 up, or it's 3 down. From 2 to negative 1 is a 3. So the amplitude is 3. The sinusoidal axis is 0 here. And the height from here to here is a 4. Even though it's going down, it's a 4. The amplitude is always positive. And the sinusoidal axis here is negative 3. So the height of the curve is from perpendicular from here to here is 2, or perpendicular from here to here is 2. And the sinusoidal axis here is 1. I always pick up the sinusoidal axis first, and then I look for my amplitude after. 1, 1, 2, 3. So that's 3 up, or go down. You can go down here. 1, 2, 3. So that's a 3. So that explains about the amplitude. All these terms will be used to derive the equation of this sinusoidal function. Another term used is frequency. Frequency is the number of cycles between 0 and 360, or between 0 and 2 pi. So between 0 and 360, the number of cycles, the number of S's, or sideways C. So between here and 360, notice we get 1, 2, 2 sideways C's. So the frequency is 2. And right here, I forgot to put in the numbers here. So let's see, we go from 0, and this is going to 30. Let's see, go with 30, 60, 90, 180. So we can go to 2 pi. So from here to here is only 1. So there's only one cycle between from here to here. Maximum down to a minimum up to a maximum. So the period is 2 pi. But the number of cycles is only 1. Frequency is 1. And right here we go between, this is 90, so that's a 30 and a 60, so this is a 60 here. And right here, this is 30, so it's a 180, so that's 210. So between, that's between 60 and 210, there's 80 degrees. We got a 210, and we got a 60. So that's 100 and, did I say 60? And this is between here, between 60 and 180. My mistake. That's a 60, and this is 210, but it's, the graph is here and here. This is the sideways S, so there's one sideways S right here between 60 and 180, and that makes it 120 degrees. So between, if there's 120 here, then it takes another 120, and then it takes another 120 to, so there's 3 cycles. The frequency is 3, because there's between 0 and 360. If I started here and drew this, kept drawing this graph over to right here, I would have 3 cycles. Frequency is 3. There's only 1/3 of between here and here was 120, so there's takes 2 more of them, 120, 120, 120, so there's 3. And right here in this one, the frequency is, this is between, this is the bottom to the bottom, so this is sideways C. So we can go, this is a -30, and right here we have, that's 210, 240. So we're on the sinusoidal axis here. It's one of the ways we could pick it up right here too if we want. So we go on the sinusoidal axis, or we go to whatever way you want to go. This is, that's a 30 right there. And you go to right here, and that's a 270, 180, 210, 240, 270. So that's 2/3, 240. And the sinusoidal axis between 30 and, so you got 270 right here, 30 here. So that creates 240 degrees. And 240 degrees is that of 360. So it's 2/3. So there's 2/3 of a cycle in this graph between 0 and 360. Or you can go between -30 and 110. So, or sorry, 210. So you can go from right here to here. So that's -30 up to 210. And if you go that far, you're going 240 degrees also. So it's 2/3. So I just wanted to mention the frequency. A lot of people don't mention it, but I want to mention it. And another term to use is period. The number of degrees or radians forming a sideways S. And notice this sine curve, sideways S. This is going up and then down. This one is down, going up. You start and you go up, come down. So you have to finish the sideways S. So if you finish the sideways S, then that's the number of degrees that's in this, is the period of the sine. The cos is the sideways C. So if we start at the max, go down to the min, and go up to the max, the number of degrees to go from here to here to form this sideways C is the period. Or if you start from the min and go up to the max and come down to the min, you get the same number of degrees. So let's look up here and look for the number of degrees. So we can use an S or we can use a C to make a difference. So if we do a sideways C from here to here, we get the period of one cycle to be 180. Or if we go from, it's easier to start here at 0 and go this way. If you start at 0 to 180, you can see. If you start here, then you gotta, from here to here, so you gotta mark these off. So that's 90, so that you can use this one. So this is a 45, that's a 90, that's 135. And this is a negative 90, that's a negative 45. So 135, if you do a sideways S from here to here, this is the sideways S. You go from negative 45 up to 135. Again, it's 180, but it's best to start here. Right? It's easier. Number 2, again, when you got this diagram, so you're going to period, it starts at 0, and you're going all the way and make a sideways C to 270. So the period is 0 to 720, so the period of this is 720. Number 3, we're going from, you want a sideways S, so we start here, this is at 60, and you're going to 180, so 60, 180, take away 60, so the period is 120 degrees. And in this one, the period is from, this is a negative 90, that's a negative 60, so that's a negative 30. And this one right here is, that's a 210. So you go from 210 to negative 30. So that's the total number of degrees of 240. So from here, there's 30 there, and there's 210 as far as here. So it's, you don't go 210 add on negative 30 and make it 180. You have to say there's 30 degrees and 210 degrees. 240 is the period. So you can either go from make an S, sideways S, or a sideways C, your choice. And the phase shift is the horizontal transition, moving it left and right. It's the number of degrees or radians in the starting point of sine or cos. Oh, I have to go back. I forgot just for a second. I said degrees or radians. If I got radians is 180, or sorry, degrees is 180, radians is 180 multiplied by pi over 360. 180 and 360 is 2. Pi, 180 is related to pi over 180. So they cancel, and so I get radians. The conversion factor from degrees to radians is multiplied by pi over 180. So 720 multiplied by pi, which is radians in terms of 180 degrees. 180 goes into that 4 times, so that's 4 pi. And I got 120 multiplied by pi over 180. The zeros cancel. 6 into the 12 goes 2, 6 into 18 goes 3. So 120 is 2 pi over 3. Notice pi over 3 is 180 divided by 3 is 60. 2 times 60 is 120. 240 is double that. So 240 multiplied by pi over 180. Zeros cancel. 6 into that, 18 goes 3. 6 into 24 goes 4. So it's a 4 pi over 3. So I can have degrees or radians. No, again, pi over 3 is 60. 4 times 60 is 240. So I can have my period in degrees or in radians. Okay, sorry about that. I forgot to do the radians. Phase shift is left or right. The number of degrees or radians in the starting point of the sine or cos circle. The sine circle starts on the sinusoidal, forming the sideways S. The cos cycle starts at the highest point and goes at the highest point. Or it can start, again, forming a sideways C. Or you can start at the lowest point. So you can start here at the highest point and form a sideways C. Or you can start at the lowest point, finding a sideways C. But if you start on the sinusoidal axis, like this, there's the phase shift right there, whatever that takes to start. Or you can go down, up, like this. So this is the phase shift. So let's look at the phase shift in each of these. If A is the starting point, find the phase shift. If A is the starting point, there's 0 there. So this is a negative 90, that's a negative 45. So that's the phase shift is a negative 45 degrees left. And if this is a phase shift, start here. Notice we're going up, and it's starting with, it's on the sinusoidal. So that would be a sine. If I started at A, I would name it with a sine equation. And number 2, the phase shift is starting at A. That's a 0 right there. So the phase shift is 0 degrees. Or if you want, I'll go back over radians after. And if I start here, is come down, I form, there's no S there, so this is a C, so that would be a cos. So if I start at A, I would be having a cos equation. And A is here, and this is a sideways S right here. So the phase shift is, that's a 90 and that's a 60. So the phase shift is 60 degrees. It's plus because it's coming to the right. And this is starting a sine. Notice complete S. So that would be, if I were using 60, I would have a sine equation. And the last one, A is right here, and this is negative 90, negative 60, negative 30, so the phase shift is negative 30, and a negative 30 is doing a sideways C, so that would be a cos. So these are some terms that I've practiced before I get into working out from a graph or from a word problem the different parts of the equation. You need to know what I just discussed. And hopefully what I reviewed those terms from a graph. So if you like my video, click on the like button, click on the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.